I tell my students about this, that calcium is more important than the sperm at fertilization because sometimes it's not the sperm that does the activation, as in Drosophila. There's other examples, by the way. So in zebrafish, the eggs seem to be activated on hitting the pond water, and there's some receptors on the surface of the egg. So that's not sperm egg fusion triggering anything there. Sperm does fuse with the egg, but the trigger for activation is not the sperm then in the zebrafish. In all mammals, then you're seeing the sperm causing the calcium change. And in fact, there's an awful lot of species like the sea urchins and ascidians, frogs that people work on, that's always the sperm causing the calcium change. So it's probably more common. But, again, it's always calcium. And there's this polysperm is interesting because there are these examples of species where you get physiological polysperm. You not only have lots of sperm fertilizing the egg, 10 or 20, but it's necessary. So newts are a good example of this. In newt eggs, you have to have 10 to 20 sperm to fuse, and each one causes a little calcium transient, and they summate to cause a big enough calcium transient to activate the egg. So, you can either have the sperm not causing any transient, it can cause a little transient that has to summate, or it can cause the entire thing. It all comes down to giving a calcium transient that is big enough to trigger development. So the strategies vary a great deal, but it's always calcium.